Here is a problem on finding the limiting reactant. We're actually gonna find three things. We're gonna find the limiting reactant. We're gonna find the mass of one of the products, and we're gonna find then the mass of the excess reactant. How much is left over? All using the same equation. So we're gonna start. We need to start off with the limiting reactant. We're given grams of each of the reactants. Remember, these over here are called reactants. And on the right side over here, products. Okay? Now, because question number 2 is finding the mass of Fe3O4, okay, so we're given both the reactants, grams of reactants. So we're going to pick, I'm going to draw my box to Fe3 from both reactants because we're going to have to find out, actually, oops, I'm doing this in the wrong one. We're going to have to find out, this one asks us to find the mass of FeO3. So when I draw my boxes, I'm going to pick that product to compare these two. So I'm going to start off with iron. So I'm just going to take this and do a dimensional analysis, follow the box, right? Starts with grams of Fe. I'm going to multiply that by the molar mass, which I get off of the periodic table, and I find Fe, and it's 55.8. And so I'm going to write 55.8, and that's grams. I'm going to turn that into grams of Fe per 1 mole of Fe. Okay, and that's going to get me right to here, to moles of Fe after I cancel grams out, right? So now I need to get over here to moles of FeO3. That's the next stop on my box. I'm going to do that by using the molar ratio, and I'm going to do that. Molar ratio is the coefficient. So I'm going to start by putting moles of Fe on the bottom. I go up to Fe, and I see the coefficient is 3. Now I'm going to pick where I'm going, which is moles of Fe3O4. And that coefficient is, there's nothing there, so it's a 1. So that'll get me to right here at moles of Fe3O4 after I cancel out, right? And really, I'm gonna go to the next step just so you can see it, to go up to grams, right? And the molar mass of FeO3, I've already found that. Did I find that? Fe3O4 right here. And I just looked these up. There's 3 Fe's at 55.8 each. There's 4 O's at 16 each. So the total is 231.4. So I go 231.4 grams of Fe3O4 per 1 mole. And I put that 1 mole on the bottom so that I can cancel those out, right? And there it is. So now I grab my calculator. And can you see this? Okay. 67 divided by 55.8 divided by 3 times 231.4, and I get 92.6. Is that what that was? 92.6 grams of Fe3O4. So let me just do the next one. 36 grams of H2O times the molar mass. And I know that's 18, 1 O, 2 H's. It's going to allow me to cancel the grams out. I'm at moles, so I'm right there. Molar ratio is 1 mole. This is where I'm going. This is where I am. Equals 4 moles. I get that from the coefficient right up there in front of H2O. So I can cancel out moles of H2O. That'll put me to right here at moles of FeO3. Now I can go back up to grams. And so I'm going to go grams of Fe3O4, which I found the last one, 231.4 grams of Fe3O4. I'd already found that out. It's right there. So I'm just going to use that again. 1 mole Fe3O4. That cancels out. And now I just grab my calculator. 36 divided by 18 divided by 4 times 231.4 that is 115 point, what was that, 7? I think that was 0.7, yes. 0.7 grams of Fe3O4. So my limiting factor is the one that produces the least amount, and that is right here. Right? That's my limiting reactant, the one that will run out first. Okay, so now that I know that, my 67 grams of Fe is my limiting factor. It will produce 92.6 Fe3O4. I basically have that done right here. That's the answer to my next question. What's the mass of Fe3O4? How much of that is produced? Well, I already found that, right? It's the limiting reactant. Here it is, 92.6 grams of Fe3O4. So the answer, 92.6 grams of Fe3O4. Because this is determined by the limiting reactant. That's why I was able to just go back and look. What did the limiting reactant produce? Well, it produced 92.6 grams. Okay, so that's answer to question 3. Last one. So this one, let me just label these really quick. This one is our limiting reactant. This one is our excess reactant. And it says, what mass of the excess reactant is left over? I start with 36, but I am not going to actually use that much. I'll have some left over. So how much do I actually use? That is the question. That's a question mark. That's a really bad question mark. How much will I actually use? So all I do is I draw a box from my limiting reactant to my excess reactant, and I go through the dimensional analysis. This is, remember, 55.8 grams of Fe. This is the molar mass per 1 mole. Fe, molar ratio. That'll let grams of Fe will cancel out. Then I go, my molar ratio is the coefficients, which is 3 moles of Fe and 4 moles of H2O go on top. And let me cancel out moles of Fe. Then I'm going to go back up to grams. And this is using the molar mass from the periodic table, right? I count up 2 H's and 1 O, okay? And that comes out to be 16 grams of H2O per 1 mole of H2O. That'll allow me to cancel my moles, and I'll end up with grams actual, right? My actual grams used. So I grab my calculator, and I go 67 divided by 55.8 times 4 divided by 3 times 16. And it's 25.6 grams of H2O is actually used. That's this one. So now I can plug that in. That's how much was actually used. I started with 36. I used 25.6. So 36 minus 25.6, and I get 10.4 grams is left over. 10.4 grams of my excess reactant, H2O, is left over. That's it. Watch this as many times as you need to kind of get it. Practice some problems from your book. Make sure you know this.